Hey guys, welcome to this video on process of induction. It's going to be a video that is going to go through some stuff that you probably haven't seen before, and the reason for that is because it is starting to get a little bit more towards the higher end mathematics of what you're going to be doing. However, you do need to know this stuff, especially for next year, and it's always good to try and prove mathematics correct or not, or come up with new theories or new ways of explaining stuff. So let's start by defining what mathematical induction is. And the textbook gives us this bit of a generic definition of that it's the process of formulating a general result from close examination of the simplest cases. So let's look at an example of what this actually means. So we're going to look at even numbers. So we know that even numbers are divisible by 2. So if I was to go, what is the first positive even number? Well, would go 2 times 1, being the first positive even number. And we could say that we just know that that's 2. What about the second? So let's go the second positive even number. It's going to be 4. Is 3 an even number? No. So that would make it the second positive one. What about the third? So again, 2 times 3 will give us 6. The fourth, and so on and so on and so on. So we can see that we've got first, second, third, and fourth even positive numbers as being 2, 4, 6, and 8. So we could, looking at these results, we could start to see that there's a pattern forming here, and we can induce that the nth positive even number, so the nth positive even number is going to be 2 times n, or we could just write it as 2n. Now, this little statement here that I've made is a summary of what our observations are. And it's the simplest cases here. So 2 times 1, 2 times 2 being those positive even numbers. We believe that this is going to be true for every single positive even number as we keep going through. What we call this statement here is a conjecture. So let's write that. So we come across conjectures quite a bit in maths, and whilst we have to come up with a conjecture in this course, we don't have to prove it. We leave the proofs of it until next year in mathematical methods, for those that are going on to do mathematical methods at year 12. So what I want you guys to do is pause the video, get this written down, and then we're going to look at an example of this. Alright, so welcome back. Hopefully you've got that written down. If you don't, please go back and get it written down. So in our example here, we've got to make a conjecture about the sum of Sn being equal to 1 divided by 1 times 2 plus 1 divided by 2 times 3, etc., up to 1 divided by n multiplied by n plus 1. Now, we're going to look at the simplest cases here where n is just going to equal 1, 2, 3, and 4. So let's get started. To do this, what we're going to do is go s of 1, which is going to be equal to 1 divided by 1 times 2, because n being 1, n plus 1 is 2, so that's going to give us a half. let's try case 2. So 1 over 1 times 2 plus 1 divided by 2 times 3. Again, n being 2 in this case. We've got n2, n plus 1 gives us 3, so that. What does this equal? So a half plus 1 over 6, which is going to equal 2/3. Try the third case. So 1 over 1 times 2 plus etc, etc, etc up. So we'll get a half plus 6 plus 1 on 12, which is going to be 3/4. Our next and final case is 4, so I'll quickly write that out. All right, and when we add all of these up together, we're going to get 4 over 5. Now, the biggest thing with mathematical induction is looking for patterns. So what we're going to do now, I'm just going to choose a different color. Let's pick yellow. We're going to look at this number here, this one, this one, this one, and its relationship to n. So the 4, 3, 2, and 1. So by looking at it, I want you guys to just have a think for a moment to see what is going on here. So what does a value of n do, and how does it relate to the answer that we've got? So think of the numerator and denominator of these fractions. Any ideas? Well, what it's doing, we could make a conjecture that Sn is just going to equal n divided by n plus 1. So we've got, when n is equal to 1, it's 1 divided by 2, because n plus 1 is 2. And what we can say for all of this, and again, let's look at case 4, when n is 4. So it's going to be 4 divided by 4 plus 1, which is 5. And so it matches this one here. It matches this one here. It matches all of them. So our conjecture is this. And we're going to say for all n being positive integers. And that's really, I know it's a little bit of a long-winded example, but that is really the process of mathematical induction. So what I want you guys to do is get this written down, pause the video, get it written down, and that's really going to be it for this video. In the next one, we're going to look at the principle of mathematical induction and start to get into the nitty-gritty of it. Hopefully that's made a little bit of sense. If you've got any questions, just ask. As always, thank you for watching.